Hello guys, I am Jayesh Gupta. This is my second task for the internship in which we are going to predict the optimum number of clusters from the given iris dataset. So before moving ahead, let's look at what all we need. So the first thing we need to do is the import all the libraries that will be requiring in this task. So the first library is NumPy, then Matplotlib, Pandas and Seaborn. Let me give you a brief introduction of the all the libraries. NumPy is used for data manipulation and Pandas also the same. Now Seaborn and Matplotlib are used for data visualization. And next step is importing the dataset. So we can see here we have load our dataset using this command pd.read underscore csv and then print our dataset using iris. Okay, then next step is I am checking the statistical description of our dataset using iris.describe command, which includes count, mean, standard deviation, minimum values, and maximum values also. After that, we are using the iris.info command by for the information about the attributes, and after that dividing these into independent and dependent features. Okay, and now moving ahead, next step is finding the optimal number of clusters using the elbow methods. So in this elbow method, first we use the k-means clustering algorithm. Then what is the meaning of the k-means clustering algorithm? It is a algorithm will be using to find the optimum number of clusters. So before we need to know what is the k-means clustering algorithm. K-means clustering is a clustering method which is used to subdivide the main cluster into smaller number of clusters or subgroups. We can see here we are using the Python library sklearn and we use importing the k-means cluster. Then this is the WCSS which we have initialized it to blank like empty array. So what is the WCSS? WCSS is the sum of squared distance between each point and centroid in a cluster. And we can see in the for loop we are initializing the k-means. Here we have initialized the number of clusters to the I, and we are using k-means plus plus and our random state is 42, so that we get our new value of the centroid, not the same value. Now we are fitting our k-means algorithm, and after this we are appending the k-means dot inertia. What is the k-means inertia? This will return the value of WCSS for the cluster we have initialized. After this, we will plotting the graph using elbow method. Elbow method gives us the value for the k, and you can see here the graph is drastically decreasing from 0 to 4. So optimal value of the cluster is 3. Now we are initializing our k-means with minimum number of clusters, that is 3. Then we are fitting our model and predicting the values. So you can see here our value is stored in k-means and the array look like this. And then we are visualizing our clusters and labeling it with the iris setosa, iris versicolor and iris virginica. And this light pink circle in between is centroid of all these cluster accordingly. So thank you for watching this video.